Okay, hello everyone. Welcome to lecture 10 of this course. Up to this point, we have been building AI agents, connecting them to workflows, and even allowing multiple agents to collaborate together. So now we are about to take the next step, which is combining all of these pieces into complete structured systems or system that is often called a pipeline. So, how are you? Have you done any of the tasks of the last 2 or 3 sessions? Tell me about your own experience with N8N. Please share it in the chat, and I will be looking at it when time comes. So yeah, please share with me whatever have you done so far with N8N. Okay, so let's talk about what's the meaning of a pipeline. So a pipeline is essentially a chain of processes where each step builds on the previous one. So instead of handling a task in a single action, we pass it through multiple stages. With each stage, we perform or the pipeline is performing a specific role and gradually shaping the final output. So in AI systems, this means that a request can move across several agents or workflow steps, each contributing something meaningful until the final result is ready. So it's like a bunch of workers who are working together to achieve a specific and bigger goal. So this approach is especially useful. Is especially useful when dealing with complex tasks that requires multiple layers of processing, and it also ensures smooth transitions between components. So nothing gets lost or misaligned along the way. So we want a professional and complete result through all these steps. So here in this lecture, we will focus on how to design these pipelines properly, and we will explore how tasks move between stages, how to keep track of progress across the system, and what challenges that you might face when building a reliable pipeline. So we will also highlight how tools like N8N can act as a backbone of this structure, which can connect and manage everything together. So by the end, you should have a solid understanding of how to design AI systems that handle complete workflows from start to finish. So let's talk about what is a pipeline. So pipelines in AI systems specifically. So pipelines are not a new concept. They have been widely used as software engineering, but they've become more important with modern AI systems. So a pipeline is simply a structured sequence of steps. Each step takes the output from the previous one, processes the output and passes it forward. So the goal is to achieve something that would be difficult or impossible to complete in a single step. So there are several common types of pipelines in AI. There are data pipelines, which focus on preparing data. They collect information from different sources, clean them, and transform these data or this data into a usable format, and then stores it somewhere accessible and reachable for the system or for the user. So this is typically what happens before any analysis or any model training, the data step. Then comes the machine learning pipeline, which goes forward by covering the entire life cycle of a model. They start with data preparation, then moves on into the feature engineering, then training, evaluation, deployment, and finally monitoring performance in production. So this is what a machine learning does in a pipeline. About the AI agent pipelines, they are more task oriented. So instead of focusing only on data or models, they focus on completing a user request by passing it through multiple agents. So, for example, a request might go to a research agent first, then an analysis agent, then a writing agent, just like the workflow that I showed you in the previous session. So until this workflow will be running until a complete result is delivered. So the reason why pipelines are so powerful comes down to few key advantages. So pipelines allow each part of the system to focus on a specific responsibility. What does this mean? So it means or makes the development easier, right? The individuality rule, and they can scale efficiently because individual stages can be optimized or expanded independently. So, and they also make systems easier to understand and debug and also maintain. And on top of that, they improve reliability by allowing validation and error handling at each step and each output. So overall, a pipeline is what makes any workflow or any system works and is ready to be delivered to users efficiently. So let's talk about task handoffs and state management. Okay, so for pipeline to work smoothly, two things are critical here. First one is how tasks move between stages and how we keep track of their process. We have seen all of this before in 8N, so I believe that you have a previous idea about what we're going to talk about here. So try to focus a little bit with me to understand better about the interior of the pipeline. So task handoffs actually refers to how responsibility is transferred from one stage or one agent to another. So the simplest form is a direct handoff, where one agent sends, it sends its output straight to the next agent. So this is a direct handoff. So in this case, it's easier to track the output or to track the data that is transformed or being transported from one agent to the next one. It's easy to track it. It's easy to debug it. It could be more reliable, while the indirect handoff, the indirect handoff, it happens indirectly by its name. So what happens here? There is a shared system like a database, for example. This shared system, or maybe a queue. So this shared system, one stage over here or one agent writes data and another reads it later. So there are no direct touch between one agent and another. Each one happens in a parallel way and does not happen sequentially. And also we have the event-driven handoff. So here, completing one stage automatically, then it triggers the next step and then moves on for the whole workflow. So when designing these handoffs, we need to make sure that the data format matches what the next stage expects it to be. So we need to ensure reliability so that no data is lost, and to keep delays as low as possible, and define clear behavior in case of any failure or any errors happening over here. So we also have something called state management. So state management is all about tracking what's happening to a specific task as it moves through the pipeline. Without it, you wouldn't know where a task is, whether it failed or not, and how to resume it if it does. So a state management focuses on a specific one task that goes on through the system or workflow. And a good state management allows a system to continue, even if it pauses or recover from errors without restarting everything from scratch. It monitors the progress in real time and debugs issues by tracing the workflow, the whole workflow. So without it, we wouldn't know what exactly has happened, why did the workflow stop, etc. Also, there are ways to manage any state. You can store it in a database or use message queues to manage tasks that are waiting in line, or maybe store large files in object storage, or rely on workflow tools that keep temporary state internally. So, yeah. And we will see how states are held in 8N right now. We have seen it before, which is the execution part, and we will be looking at it again right now. Okay, so designing pipelines within 8N. How does this happen? So this is where an 8N becomes very, very useful. As we have seen before or said before, an 8N is actually the orchestrator that connects all of the parts of the pipeline, and it manages the whole process, how the data is transferred between each node, and how the flow is happening, what errors that are occurring. So N8N makes it easy, right? We have seen this before. It makes it so easy to integrate different services and different tools, including AI agents specifically. And it provides strong capabilities for transforming and routing data, also handling errors, controlling executions, etc. So pipelines in the context of an 8N can run on schedules, right? It can react to external events or be even triggered manually or by external event or triggered by a specific schedule. So when building a pipeline in 8N, you work with a set of core components. Webhooks can be used as entry points as a start to receive incoming tasks. Code nodes allow you to write custom logic or handle complex transformations. Also, HTTP nodes are used to call external APIs, including AI models or LLMs. And data can be structured and combined using set and merge nodes, right? We have seen set and merge nodes before. It helps us to take the output of multiple nodes and then combine them into one node or one output, a specific output. So, for example, the LLM can see the text that is coming from, let's say, for example, that is coming from WhatsApp or Messenger or Instagram or TikTok or any platform. It can see it as one, and it can be handling a whole bunch of platforms in one AI agent. So code nodes allow you to write Yeah, we have seen we've said this before. Okay, so let's move on. Oh yeah, we haven't said about the F and switch. So data, it could be structured and combined, right? Um, well, decision nodes like F or switch, it helps route the tasks based on a specific condition. So yeah, we have seen this before. It's not new, I guess. We are only wrapping the concept of pipeline into the N8N workflow. Okay, so we can also connect a database to store uh, intermediate results and also to track progress, etc. So if needed, queues can be introduced for asynchronous processing, and importantly, N8N allows you to define dedicated error handling paths so failures can be managed gracefully. Okay, and to make this more concrete, imagine a content generation pipelines. We have seen this in the previous session. So it starts with an idea. What is your idea? What is the input that you have in your mind, which will expand later into multiple articles, topics, using AI model or an LLM. Then another stage of this workflow, it collects relevant information from reliable sources. And after that, a writing agent produces a draft, followed by a review stage that improves quality and checks accuracy, etc. And before publishing, we could add something we've talked about before, which is human review, which is human in the loop. So a human in the loop could be introduced into this workflow and approves any content, etc. And finally, the approved article is automatically published to the platform, maybe a post to Facebook, maybe a blog to WordPress, etc. So each stage here has a clear role, and the task flows smoothly from one step to the next step. The errors are handled gracefully by adding it to the execution tab or the execution part. So each step is perfectly handled with an 8N. So let's talk about N8N fastly before moving on to the conclusion. Okay, so as you can see here, we have the workflows um, tab over here and the credentials tab, and also we have something called executions tab. So as you can see here, all of the execution that you are handling, so it could be stored here, whether it was a success workflow, or maybe let's filter these out and get all the error states. So whether it was successful or an error, it will be all handled over here. Also, we can filter it by a specific workflow, etc. We can have a whole of filtering to the execution part. Okay, um, I guess that's it. Okay, so let's wrap this quickly. So what we talked about today, it was a very short session because we only talked about a principle of a pipeline. So here we focused on how pipelines help move from simple isolated tasks to fully integrated AI systems by breaking complex problems into structured stages, and also managing how tasks move and evolve across those stages. So we can build systems that are far more powerful and reliable. So the main ideas, or the main idea here to remember that pipelines transform inputs step by step, and they improve clarity and scalability, and they rely heavily on proper task handoffs and also state management. So tools like N8N makes this process much easier by providing a flexible way to connect services and also control workflows. So that's it for today. I just want to go on for the next for the previous sessions. What was it called? Okay, maybe we haven't named it. Okay, no, it wasn't this one. Okay, so I lost it. Okay, we have seen before the multi-agent. Okay, I guess it's called multi-agent. Let's search for this one. Okay, no, is it what? Okay, so we have seen the multi-agent workflow in the previous session. We have talked about how each step, each agent handles a specific task. Oh no. And then hand off the output of this task or of this stage into the next one. So it could be and it could be handed as sequentially or maybe in a parallel way, etc. So anyway, it does happen. It all depends on how the workflow, or I'm sorry, the data flow is going on from one node to the next one, how we handle each node, how we handle the data, and to make sure that the specific format of this output is of the next one, next node. How does it expect these format to be exactly? So thank you so much. Thank you for attending this course or this session. In the next session, we will be talking more about the project capstone, or the capstone project. I will show you how to build a reliable project, something that is worth of maybe selling. So I will see you next session. Thank you so much. If you have any questions, if you have tried N8N before, please go ahead, tell me in the chat. If there's nothing else, we are ready to wrap this session up. Thank you. Okay, so Jaya, I guess that's it.
Thank you, Myra. Thanks for the session. Thank you all for joining. See you in the next session.